Welcome to CSEGuru. In this session, we will discuss Quantitative Aptitude by S Agarwal and the topic is Numbers MCQ Part 18. Problem number 86. What least value must be assigned to star so that the number 86325 star 6 is divisible by 11? So the divisibility rule for 11 is sum of odd digit minus sum of even digit that should be equal to either 0 or divisible by 11. That number should be divisible by 11. So here if you are considering the sum of the odd digit is 8, 3, 5 and 6. So 8 plus 3 plus 5 plus 6 minus sum of even digit is 6 plus 2 plus star. So this is 22 minus 8 minus star. So here we will get it as 14 minus star. So what may be the star value if we are implementing? We will get either the difference will be 0 or it should be divisible by 11. So here if you are applying value 3, star is equal to 3 if you are applying, we will get 14 minus 3, we will get it as 11 and this number is divisible by 11. So the correct answer is option C, 3. Next, problem number 87. A number 476 is divisible by both 3 as well as 11. The non-zero digits in the 100th place and 10th place respectively are option A is 7, 4, option B is 7, 5, option C is 8, 5. So here, instead of these two stars, we will replace these values. That is option A, option B and option C. Then we will check whether that number is divisible by 3 as well as 11. So first we will replace the number with the first option, that is 7 and 4. That is 4, 7, 6 and 100th place value is 7 and 10th place value is 4, 0. So first we will check the divisibility by 3. Divisibility rule for 3 is sum of the digits should be divisible by 3. And the divisibility rule for 11 is sum of the odd digit minus sum of the even digit should be either 0 or that value should be divisible by 11. First we will check the divisibility by 3. If it is possible, then we will check the divisibility for 11. So first for this number with option A, we will check its sum, whether it is divisible by 3. So 4 plus 7 plus 6 plus 7 plus 4 plus 0. So the answer is 28 and this is not divisible by 3. So no need to check the divisibility by 11. We will check the second option, that is with the 7 and 5. That is 4. So this is option A and option B 4, 7, 6, 7, 5, 0. So its sum is 4 plus 7 plus 6 plus 7 plus 5 plus 0. And its value is 29 and this is also not divisible by 3. Then option C 4, 7, 6, 100th digit value is 8 and the 10th digit value is 5. So 8, 5, 0. Its sum is 4 plus 7 plus 6 plus 8 plus 5 plus 0. So if you are considering the value is 30 and it is divisible by 3. Now we will check with the same number whether it is divisible by 11. So divisibility by 11. So sum of odd digit, that is 4 plus 6 plus 5, that is 15. And sum of even digit, that is 7 plus 8 plus 0, that is also 15 and its difference if we are considering, that is 0. Yes, it is divisible by 11. So option C is divisible by both 3 and 11. So the correct answer for the 100th place is 8 and 10th place is 5. So the correct option is C. Next, problem number 88. Which of the following number is divisible by 3, 7, 9 and 11? So the divisibility rule for 3 is sum of its digits should be divisible by 3. And it is applicable for 9 also. That is, sum of its digits should be divisible by 3. And 11 in the sense, the difference between the sum of the odd digit and sum of the even digit should be either 0 or it is divisible by 11. And there is no specific divisibility rule for 7. So if the number is divisible by 3, 9 and 11, then we will check directly with the number 7 whether it is divisible. So first option we will take it. And first we will check the divisibility for 3 and 9. So 6, 3, 9. So the divisibility rule for 3 and 9 is sum of the digits should be divisible by 3. So it is 18. Yes, it is divisible by 3. Next we have to check the divisibility by 11. So sum of the odd digit is 6 plus 9 minus sum of the even digit is 3. So 15 minus 3, that is 12. So this is not 0 and this number is not divisible by 11. So it is not possible. Next we will check for option B. 2079 and divisibility rule for 3 is sum of its digit should be divisible by 3. So it's 18. Yes, it is divisible by 3. Next, divisibility rule for 11 is sum of the odd digit minus sum of the even digit. We have to get either 0 or it is divisible by 11. So 2 plus 7 minus 0 plus 9. So it is 9 minus 9. We will get it as 0. Yes, it is divisible by 11. Next, we have to check divisibility by 7. And 2079, whether it is divisible by 7. Yes, it is divisible by 7. So the correct answer is 2079 and the correct option is option B. For confirmation, we will check for C and D also. So option C, if you are checking 3791, divisibility rule for 3 is sum of the digits should be divisible by 3. So it is 20. No, it's not divisible by 3. And option D, if you are checking 37911, sum of the digit is 3 plus 7 plus 9 plus 1 plus 1. That is equal to 21. Yes, it is divisible by 3. Next, we need to check divisibility by 11. So sum of the odd digit is 3 plus 9 plus 1 minus 7 plus 1. So 13 minus 8, it is 5. No, this is not divisible by 11. So the number is divisible by 3 and 9, 11 as well as 7 is option B, 2079. Next, problem number 89. The value of P when 4864 into 9P2 is divisible by 12. So the divisibility rule by 12 is, so the number should be divisible by 4 and 3. That is 4 into 3. So the simple logic we will implement here is, we will check this first number whether it is divisible by 4, and obviously the second number, it should be divisible by 3. Then only its multiplication will be divisible by 12. So the first number we will check it, that is 4864, whether it is divisible by 4. Yes, it is divisible by 4. So obviously the second number, it should be divisible by 3. So 9P2, if it is divisible by 3 means sum of its digits should be divisible by 3. So sum of its digits is 9 plus P plus 2. That is 11 plus P should be divisible by 3. So now for this P value, we will apply option A, B and C. So option A is 11 plus 2 and option B is 11 plus 5. Option C is 11 plus 8. So 11 plus 2 is 13. It is not divisible by 3. And 11 plus 5 is 16. It is not divisible by 3. 11 plus 8 is 19 and it is not divisible by 3. So all these three options we are not getting. So obviously the fourth option, none of these. Next, problem number 90. Which of the following number is exactly divisible by 24? So the divisibility rule for 24 is, the given number should be divisible by 3 and 8. So the divisibility rule for 3 is sum of digits should be divisible by 3. And the divisibility rule for 8 is last 3 digits should be divisible by 8. So now we will check the divisibility rule for 3 and 8 for all these 4 options. Option A, 3, 5, 7, 1, 8. So divisibility rule for 3 is sum of the digits should be divisible by 3. So its sum is 24. Yes, it is divisible by 3. And the divisibility rule for 8 is last 3 digits. That is the 7, 1, 8 should be divisible by 8. And this is not divisible by 8. Now we will check option B. That is 63810. So the divisibility rule for 3 is sum of the digits should be divisible by 3. So its sum is 18. Yes, it is divisible by 3. And the divisibility rule by 8 is last 3 digits. That is 810. Should be divisible by 8. No, it's not divisible by 8. Next, option C, 537804. So its sum is 5 plus 3 plus 7 plus 8 plus 0 plus 4. So the sum is 27. Yes, it is divisible by 3. Next, we have to check the divisibility by 8. That is, last 3 digits should be divisible by 8. 8 not 4. Obviously, it is not divisible by 8. It is divisible by 3 but not divisible by 8. Next, option D, 3125736. And divisibility by 3 is 27. Yes, it is divisible by 3. And the divisibility rule by 8 is last 3 digit. That is 736. Yes, it is divisible by 8. So the correct option is the number exactly divisible by 24 is 3125736, option D. Thank you for watching this video.